right? And it's always better for you to try it yourself, because if you see how I do this, if you just stare at me while I do the solution, you're not learning it really. Right? So, and just copying my solutions is not a good approach. And if you thought about this, you don't need to have the final result. That's not the important task. But to think about it yourself, how would you approach it, is the best preparation for the exam, I think. Right? Because maybe the exam questions have a little twist in there, such that you can't copy and paste something that you see here that I do. Good. So, what could be an idea of how we could use this information and tie this back to the state prices step? So how would you set this up?
Can maybe start with putting both sides of this equation, like 237 PU plus 83 PB is our present value and code.
Yes. And which number is that exactly?
We can take this one, like
Exactly. So that's exactly the first big. So basically, what you do is you have to put down two equations to solve for two unknown variables. You just said the first one, right? So you basically use the two state prices, which are unknown here, to compute the price of the security that you have, and you know the result because I gave it to you here, which is 136. So that's the first line. So the price of this, 136.3. Has to be equal to the value of the replicating portfolio using the elementary securities. So that is 237 times the state price for the upstate plus 83 times the state price for the downstate. So you have one equation which implicitly defines those two state prices. Okay, one equation is not enough. We need two equations for two unknown variables. And then solving this will be just a system of linear equations that you know from high school, basically. So what's the second equation that we could use?
The formula 1 divided 1 plus interest-free rate.
Exactly. So from the risk-free rate here follows that the sum of two state prices has to be equal to 1 over 1 plus the risk-free rate. And the number here was weirdly chosen such that this number gives you a nice result. So the sum of the two state prices is 0.1.
We don't have the time, so we just write 1 plus.
It's a 1 year setting here, so we use 1. But, it doesn't actually matter the time exponent here, because you could always say I use the interest rate for the appropriate time period. So if you use a 5-year rate there, then you don't have to take exponents. So it's probably overly rigorous when I wrote down the formulas. Time doesn't play a big role here. It's a one-period modeling. Okay. So this first equation that you see in the box is an important one. Like, this will be used several times. And for some practice problems, I will actually tell you what the state prices are, but you need to figure out how to use them. Again, the benefit of using this here is that I don't require risk premium. So I can use the same strike prices state prices to compute the values of many different securities with different risk. And this would be, for example, something that you could use in a corporate context when you look at capital structures. Different capital structures have different risks. The more debt you have, the more risky your position becomes as an equity holder. It's the so-called leverage effect. So we have one chapter at the end talking about credit risk, where I briefly go over the basics of that. So there it might be pretty useful to have something like this, which doesn't depend on risk. So let's quickly solve this, or kind of maybe amend this. So what we basically have to do now is we have to kind of separate, exchange one of the two state prices. We could use this one here, and then use the equation from the top. So this state price here should be 0.9 minus pi u. Now we can simplify this here. So u plus 136.3 equals 2. 237 minus 83 times the first stake price, IU, plus 0.9 times 83. So our stake price for the upstate is going to be 136.3 minus 0.9 times 83 divided by 237 minus 83. And if you plug this in your calculator, you get 0.4. From this equation here, we can then compute the value for the downstate, which is then 0.9 minus pi u, and that should be then 0.9.
I actually tried. I had like similar numbers in the term of I had answers below 1, and I thought that I'm doing something wrong, and just didn't continue.
Yeah, so if you look at this relationship here, right? So the sum of all stake prices actually is usually smaller than 1 if you have a positive interest rate. So that shouldn't just worry you if you have small numbers here. Right, so only if you have negative rates, the sum can be above 1. So typically they're below 1. Right, and it might not be kind of, I've chosen the numbers here in this example that I made up to be kind of round numbers, or round decimals, or 1 decimal accurate. But you can have very kind of weird numbers, 0.375 or something, that's all perfectly fine. It really depends on if you choose a weird interest rate like this here, you will get nice numbers for the stake prices. If you choose an interest rate like 5% or 2%, you will get weird numbers for the stake prices. So you can't have like both, unfortunately. So then let's apply this once more to kind of show you how to use this information. Now we have another security here. We don't know the price of that security. Has very similar cash flows, but just flipped basically. It's with the 83 in the upstate and the 237 in the other scenario. Right. So the computation of the price should be now, given our formula, pretty straightforward. So you always use the cash flows as kind of an information. How much of the elementary securities do I have to buy? So that's about 83 of the first security. So 83 times. And the price of the first security was pi u, and the price, the quantity of the second security is 237. Then we can plug in the numbers that we just had. Just the 0.1 here. And then we get 151.7. And it really doesn't matter what numbers you use, what cash flows you have. You can always use this principle. Maybe one thing on the stake prices, we've talked about the upper limits. There is a lower limit, so stake prices should be positive. They should not be negative. Right? So that's something that we can. If stake prices are negative, then we would have an arbitrage opportunity actually. So that's one of the things that Arrow proved in his thesis, is like he was going through all these theories and testing them, kind of saying, okay, in arbitrage-free markets, those things have to be positive. So that's one of the things that we do know.
It's like we shouldn't lose anything. Right?
Exactly. So if you have a security like this, which has positive cash flows in all scenarios, it must have a positive price. Right? So positive cash flows should have a negative price. Otherwise, it would be an immediate arbitrage opportunity. You buy the security, you get the positive cash flow in the future, and on top of that, negative price means you get money on top of this today. Okay? So that would be a clearer arbitrage opportunity. Right, so, so there are many asset pricing theories that kind of formalize this and kind of write down conditions for like prices and so on. We're doing this a little bit actually in a later chapter when we're going to talk about stock options. We're going to derive with you kind of a sensible lower and upper value of the prices, which are independent of probabilities, basically, only using arbitrage as the guiding principle. So that's something that's very often done in theory. Do we have any questions regarding those calculations?
Are we going to need to use the upper formula with premiums in exam?
Well, this kind of is our standard approach for pricing assets, so the present value method should be something that you should be able to apply, right? And I just wanted to make sure here, or clear here, that those two approaches are not contradictory. You don't have two choices and can end up with two different prices. So they're always the same, and it just depends on what information is provided. So if you have information about a discount rate, then obviously just go ahead and work with the present value method. The state prices have some advantages for derivatives. That's where they predominantly use end theories, basically. So there's depending on how much time we have at the end of theory by two guys called Modigliani and Miller, they use this, for example. So, but most of the time, for example, if you compute values of stocks and bonds, you would probably use the present value approach.